Okay, so dear students, next in the continuation, we will move on to the next scheduling algorithm. So that is priority based scheduling. Okay, understand here. So in the previous sessions, we have seen okay, FCFS, first come first serve, shortest job first, and next round robin, and also longest job first. Okay, remember along with this, we have seen the important thing. Okay, that is the CPU time and IO time concept. So hope you have revised the notes properly, and whatever the related questions if you are having in the workbook, so please try to solve them from the CPU scheduling. So I will tell you clearly, I will give the proper instructions once this topic is completed, how to do the workbook and what to do, what not to do. Okay, so I will tell you everything. Okay, so don't worry. So whatever the questions you find, okay, please solve. Okay, if you don't get anything, okay, don't worry about that. So next, we'll move on to the next scheduling algorithm, that is priority based scheduling. So as usual, we'll define the two parameters. So one is the criteria of the algorithm and next mode of the algorithm. Understand here. So one is the criteria and next is a mode. So criteria will tell you on what basis the algorithm will work, and mode will tell you algorithm is preemptive or non-preemptive. Okay. Now tell me, so priority based scheduling, it means what? Whenever more than one process is ready for execution, more than one process is ready for execution, the decision making of selecting the process will be done based on the priority. Based on the priority. Okay, right. So where the priority will be available, priority will be there for every process, and that will be the attribute of the process, and where the priority of the process will be present in the PCB. Okay, process control block. So every process will be given assigned with the additional parameter of priority. Okay, you know that already I discussed. Okay, so criteria in the algorithm is priority. Okay, and next mode, we are having two different modes, non-preemptive and preemptive. So we will take up the non-preemptive priority first. Non-preemptive priority. Okay, so note down the first question. So in this, every process will have the additional parameter of a priority. Okay, so note down the first question. I will explain. So let's say we have a priority, process number, arrival time, and bus time. So they are the process numbers. So arrival times, okay, so bus times are given to you, and I am writing the priorities also here. Okay, so these are the priorities given to you. Okay, so fine. So first question I will explain, the next question you can solve. Okay, so first just listen, okay, how I am solving. So it is a non-preemptive priority, so that is very easy. So now look at here. So non-preemptive priority. So as usual, time always starts at 0. Time always starts at 0. At the time 0, is there any process available? Okay, only P1 is available. Now remember, before we discuss, so when you are having priority numbers here, so which one is considered as a high priority and which one is considered as a low priority? So that you have to think. Remember, in the question, he has to clearly clarify what is the strategy is following. Like for example, lowest number as a highest priority or highest number as highest priority. Okay, so anything you can follow. Is that clear? So in our question, I am following highest number as a highest priority. Let's say I am assuming 8 as a high priority. So sometimes in the question ना you can also give what lowest number as high priority. मतलब क्या है, ये 3 को high priority भी कर सकते हो. Is that clear, right? So anything is okay possible. Okay, but remember you should give properly in the question. Okay, if is not mentioned anything, okay, what is the default you have to follow? There is no default. Okay, if nothing is given like that, it is a wrong question. Simple. Is the point clear, right? So don't apply your own assumptions. Okay, you can design the algorithm any manner. So is not giving any highest number as highest priority or lowest number and lowest priority, or if he not mentioned anything, it's a wrong question. Simple, right? Now these are the process numbers. Okay, arrival times are given, bus times are given. So first time always starts at 0. Now tell me, at the time 0, which process is available? Only P1 is available. Now understand here, if you observe all the processes here, who is having high priority? Okay, we are having high priority is what? P5. So remember, even though P5 is having high priority, we are not going to start with the P5 first, because P5 coming at what time here? 8. Okay, so P5 तो अभी available ही नहीं है, so available ही नहीं है तो उसके बारे में सोचना ही नहीं है. Remember, you need to think only among the available processes. If it is not arrived into ready state, what you will do? Nothing. You should not do anything. Okay, right? So don't think about not available process. Think about only available process. Okay, right? So at the time 0, only P1 is there. So no confusion. So directly start with the P1. Okay, directly start with the P1 first. Now P1 requires how much time here? 3. So it will complete at what time here? 3. So it is a non-preemptive. So you have to execute total execution. And next, once P1 completed, so look at here, present time is 3. By the time 3, if you observe, what are the other process available? Okay, by the time 3, only P2 available again. Okay, don't confuse that. Okay, only P3 available. So remember, only P2 available. So when only P2 available again, no need of any decision making. अगर एक ही प्रोसेस है तो क्या डिसाइड करोगे? कुछ भी नहीं करने का, सो सीधा इसी को चलाने का. सो डायरेक्टली एग्जीक्यूट ओनली प्रोसेस P2, राइट? सो एग्जीक्यूट द प्रोसेस P2. ओके, ओनली वन प्रोसेस देयर, right? So P2 requires how much here? 6. So that is the 3 plus 6. How much is that? 9. Is that clear? So now P2 completed, right? Now once P2 completed, present time is 9. So by the time 9, if you observe, what are the other processes available here? Okay, by the time 9, if you observe P3 available, P4 available and P5 available. Okay, so now, okay, look at it, it's coming at 4, it's coming at 6, coming at 8. So all these 3 processes are available. So among these processes, now you have to select one of them. Among this available process, you have to select one of them. Now how do you select one of them? Based on the priority. Remember, among the available, you have to select one of them. How do you select one of them? Based on the priority. So which one you select now? Whichever is having high priority. Now among these, who is having high priority? Look at here. This having priority 6, this having priority 5, this having priority 8. So who is having high priority here? P5. Okay. So take the P5 next. Okay. So P5 requires how much here? 7. So 9 plus 7. How much is that? 16. Okay. So now P5 completed. Now P3 and P4. Among these two, who is having high priority next? Okay, look at here, P4. P4 is having, because इसका देखो, इसका 6 है priority, इसका 5 है. So high priority किसका है? P4. Simple. So take the P4, right? So P4 requires 5. So that is 21. And the last one is your P3. So next low priority. Okay, that is P3. P3 requires 8. So that is 29. Okay. So this is how you solve the problem. So take out the completion time. Find out the answer. Find out the answer, take out the completion time. So I'm writing the values here. Completion time, turnaround time. You have to improve the speed and accuracy. You can simply pause the video. First copy this. Copy karke, okay, just pause the video and solve the answer. So find out average turnaround time, average waiting time. So P1 completion time is 3, P2 completion time 9, okay, P3 29, P4 21, P5 16. So turnaround time 3 minus 0 is 3, this is 7, okay. So 29 minus 4 25, 21 minus 6, okay. How much is that? 15, correct? 15. And okay, 16 minus 8, that is 8. Okay, that is turnaround time. And waiting time also you find out, turnaround time minus burst time. Okay, all of you know the formulas already. So 3 minus is 0. So this is 1. And this is how much here? Okay, 17. Okay, and this is a 10 and this is a 1. Okay, total of this. Okay, so this is 40, 48. Okay, 48. Okay, 58. 58. 58. Okay, this is 29. Okay, perfect. So average turnaround time, so that is 58 divided by 5, and next is 29 divided by 5. So how much is this here? 11.60, and this is 5.80. Okay, so answer up to 2 decimals. Okay, is this visible? Last line. Okay, right. So now understand here. So 11.60 and 5.80. Right. So this is how you have to solve the problem. Now remember, so what is more important again? The calculation is important. Okay. So we'll take up the next question. So before that, okay, note down one statement. Note down one statement. Keep it as note. Keep it as note. Note down. If the priority of the processes, if the priority of the processes are matching, if the priority of the process are matching, then schedule the process. Then schedule the process which has lowest arrival time. Then schedule the process which has the lowest arrival time. Okay. So understand here. So same thing. Okay, I think the point is very clear. If the priorities are matching, let us say for example, this is also having priority 8 and this also having priority 8. So दोनों का priority match हुआ, तो अभी दोनों available है, दोनों का priority match हुआ, तो क्या करोगे, किसको पहले चलाओगे? Based on the lowest arrival time. So which one you select now? This is coming at 6, it's coming at 8. So which one you select now? Okay, P4. Is that clear? So if the priorities are matching, schedule the process which has lowest arrival time. Okay, right. So that's how you have to solve the problem. So take out the next question. Okay, next question you need to solve. Copy the question properly. So take out the next question. Okay, so copy this, non-preemptive scheduling only. Okay, so same, I am following the highest number as the highest priority. So copy this question. So it is a good question. So calculation is important. Calculation is important. Okay, it is a good question. Same, highest number as highest priority. So which one is having high priority here? Okay, P5. So this having highest priority. Okay, highest number as highest priority. So think carefully and solve. Think carefully and solve. So I'll wait 10 seconds. Next video you see the solution. Next, so let's look into the solution. Okay, I think all of you solved it. So let's see how you solved and okay, how I am solving, what is the right answer. So if you already solved, just check the okay answer only directly. No need to watch complete video. Okay. So first process coming at the time 2. So look at here, first process coming at the time 2. So okay, till the time 0 there is no other process available in the system. So 0 to 2 CPU will be idle. So at the time 2 only P4 is available. Okay. So only P4 available, so no confusion, directly start with the P4 first. Now P4 requires how much here? 4. Okay, so directly execute 4 seconds. So 2 plus 4, how much is that? 6. Now present time is 6. Now understand here, by the time 6 what are the other process available? Time 6 तक नया process कौन आया? तो क्या देखना? Arrival time देखना. Arrival time देखो, time 6 तक कौन कौन आया? देखो P2 आ चुका है क्योंकि ये 4 पे आया, P6 आ चुका है, P3 आ चुका है, ये 6 पे आया था और ये भी आया था और ये भी आया था, इसलिए सो अभी कौन कौन अवेलेबल है? अवेलेबल कौन है? P2, P3, P5, P6, राइट. सो अवेलेबल में एक को सेलेक्ट करना है. अवेलेबल में एक को सेलेक्ट करना है. कैसे सेलेक्ट करोगे? बेस्ड ऑन द प्रायोरिटी. So who is having high priority among the available? Look at here, this having priority 8, this having 7, this having 9, this having 8. So who is having high priority among the available here? That is P5. So take the P5 next. Okay, so P5 requires how much here? 9. So that is how much here? 15. Okay, so that is the P5 completed. And next, after that, if you observe, by the time 15, okay, your P1 is also arrived. P1 is also arrived. So next, what is available now? Okay, look at here. P1 available, P2, P3 and P6. So among the available, next high priority is what? Okay, look at here, that is 8. So both are having this, both are having same priority. So if the priority are matching, so what do you follow? Arrival time. Priority are matching, you follow the arrival time. So look at here, this having arrival time of 3, this having arrival time of 4. So अब बताओ, so दोनों में कौन पहले आया? Okay, P6 पहले आया. So take the P6 next. Okay, take the P6 and P6 requires 8. So that is how much here? 23. So 15 plus 8, 23. Correct? And next, after that you take what? Next is your P2. Okay, so take the P2 next. Okay, P2 requires 9. So that is how much? 32. Okay, right, 32. So next, okay, now P2 is completed. Now next, after that, what is the next high priority? Okay, that is your P3. Okay, P3, P1 दोनों available है. So इसका 7 है, इसका 4 है. तो next high priority is what? P3. So take out the P3 next. So next high priority P3. P3 requires how much here? 7. So 39. And the last one is your P1. Understand here, last one is P1 and P1 requires 12. So that is okay, 51. Okay, 51. So is that correct for everyone? Okay, check karo. Okay, pura Gantt chart. So next, now take out the completion time fast. So this is 51. Okay, this is 32. This is 39. This is 6. And this is 15. And this is 23. Okay, right. So turnaround time, completion time minus arrival time. 51 minus 8. How much is that? 43. Okay, 43. And this is 28. And this is 33. This is 4 and this is 10 and this is 20. Okay, so check the values properly. And next, turnaround time, so that is 43 minus 8. So 43 minus 12. Turnaround time minus bus time. So I made the printing mistake. So understand here. So this how much here? 31 and this is 19 and 26. Okay. So this is 0 and this is 1 and this is 12. So check the values properly. So turnaround time total is how much? 138 and this one 89. Okay. So total 6 processes are there. So 138 divided by 6 and that is 89 divided by 6. How much is this value? 23. So 20.00 and this one 14.83. Okay, so now understand here. So make the proper calculation. Is that clear? So calculation you can check, I think. So if any small mistake is there also there, okay, check, make the correction. Okay, so concept is clear. But remember, don't use calci, okay, when you're solving, okay, when you're sitting and watching the video. So you can directly solve that properly. So this is how you solve. So in the exam you have to type. If it is a numerical type question, okay, if it is asking for up to 2 decimals, you have to type as what? 23.00 and here also 14.83. So this is how you solve the problem. Now remember, so this is simple, okay, we discussed the non-preemptive, okay, priority. So I am changing the mode of the algorithm to preemptive priority. Okay, note down. Next, आप लोग heading लगाओ preemptive priority. So same thing, priority based scheduling and the mode I am changing it to preemptive. Same, okay, keep the heading priority based scheduling. Criteria is a priority but mode is a preemptive. So again keep the heading once again. Okay, so okay, preemptive means what? Simple, okay, you know that already. Preemptive means okay, for every one unit of time you need to identify the high priority process. Understand carefully. For every one unit of time you need to identify the high priority process. So I'll explain the first question. Okay, so I think you can understand easily. Okay, so just copy the question. Okay, in case if you understood, you can solve it directly. नो नीड टू वॉच द वीडियो. ओके, अगर तुमको समझ में आया सो पूरा डायरेक्टली आप खुद से कर सकते हो. सो जस्ट नोट डाउन द क्वेश्चन. सो 1 2 3 4 5. सो 0 1 1 2 3. So let's say 5 4 3 6 8. Okay, so let's say this is 4, this is 3 6 8 5. So same thing, I am following highest number as the highest priority. Okay, so this is the question given to you. Okay, so you're having 5 processes and the highest number is the highest priority. So now we need to think very clearly, like whichever is having high priority, so that you will schedule. Same thing, for every 1 unit of time you check the high priority process. Okay, so I'll explain this question. So anyway, so in case if you are not clear, so first listen my question and second question anyway you will solve. Okay, so time always starts at 0. Okay, at the time 0 which process is there? Only P1 is there. So only P1 is there, so no confusion, directly start with the P1 first. So P1 requires 5, but you will execute how much time? Only 1 unit. So execute for 1 unit, so that is 4. Now present time is 1. Okay, by the time 1, is there any other process also available? Yes, time 1. Okay, P2 P3, these two are available. Now think and tell me, now how many are available here? 1 2 3, these 3 are available. Among the available you select one of them. How you select one of them? Based on the high priority. So this having priority 4, this having priority 3, this having priority 6. Who is having high priority here? Okay, P3 obviously. So take out the P3 next. Now P3 requires how much here? 3 units. But you will execute only 1 unit. Remember that requires 3, but you execute only 1 unit. So that is 2. Okay, so इसका remaining time क्या होगा? 2 होगा. Next, present time 2 है. By the time 2, is there any other process also available? Yes. देखो P4 आ चुका है. देखो अभी कौन कौन अवेलेबल है? 1 2 3 4 अवेलेबल है. सो अवेलेबल में हाई प्रायोरिटी किसका है? ओके, P4 का है. सो टेक आउट द P4 नेक्स्ट. सो P4 रिक्वायर्स हाउ मच हियर? 6, बट एग्जीक्यूट ओनली 1 यूनिट. सो दैट इज 3 एंड इसका रिमेनिंग टाइम क्या होगा? 5 होगा. एंड नेक्स्ट, प्रेजेंट टाइम इज 3. बाय द टाइम 3, इज देयर एनी अदर प्रोसेस आल्सो अवेलेबल? यस, P5 भी अवेलेबल है. नाउ रिमेंबर, नाउ ऑल आर अवेलेबल. सो लिसन टू मी फर्स्ट. वंस ऑल द प्रोसेसेस अराइव्ड, once all the processes arrived, no need of checking one unit of time, because एक बार सारे process आ चुका है. Once all are arrived, you clearly know who is having high priority. You clearly know who is having high priority. So once all the processes arrived, no need of checking one unit of time. So just continue with the high priority process. So now tell me, so all are arrived now. Now who is having high priority here? P4. So just continue with the P4 with the total execution. How much is that? 5. So 3 plus 5, how much is that? 8. So now look at here. So P4 completed. Once P4 completed, who is the next high priority process here? 1 2 3 5 में next high priority किसका है बताओ? P3. Okay, look at here. इसका priority 4 3, इसका 6, इसका 5. So next high priority P3. So take out the P3 next. So P3 requires how much here? 2. So that is 10. Now that becomes 0. Now P3 completed. Now present time 10. Who is the next high priority process here? Okay, P5. Look at it, इसका 4 है, 3 है, इसका 5 है. Next high priority P5. So take out the P5. So P5 requires how much here? 8. So that is 18. And the next 1 2 में high priority किसका है? 1 का है, P1 का है. So P1, okay, 4 high priority. So that requires 4. So that is 22. And the last one is your P2. So P2 requires how much? Okay, 4. That is 26. Okay, is it visible this part? Okay, 26 is visible, right? Okay, so fine. So take out the completion time and find out the answer. So completion time, so turnaround time and waiting time. So completion time, P1 completion time 22 and P2 is 26 and P3 10, P4 8 and P5 18. Okay. So P5 18. Next, okay, you got the completion times. Now you can find out the turnaround time. So completion time minus arrival time. So that is 22. Okay, so this is 25 and this is 9, this is 6 and this is 15. Correct? And next, so waiting time, you want turnaround time minus bus time. So you know you are having two things. Just subtract 22 minus 5. So that is 17. Okay, and this is 21, this is 6 and this is also 0. 6 minus 0 is right. And next this is how much here? Okay, 7. So okay, 15 minus 8, that is 7. So okay, you got the values here. So find out the total of this how much? 77. This is 77 and this one 51. Okay, so check karo, pura properly check karo. So now okay, that is 77 divided by 5, average निकाल रहे हैं तो 5 plus है. So this is a 51 divided by 5. Okay, so this is how much here? Okay, this is a 15.40 and this one 10.20. Correct? Okay. So any calculation, you please check it out. Okay, verify once again. Okay, right. So this is how you solve the problem. Okay, so preemptive priority. For every 1 unit of time, you check the high priority process. Okay, so if you want to copy, anybody want to copy, you can just pause the video and copy. Next, I will give the next question. Okay, after that we will pause the video. Next question will be good question. So आपको solve करना है. Remember, I am making you to practice more number of questions. Okay, because definitely 2 marks question will come from this small topic. Okay, CPU scheduling I'll discuss around 6 to 8 hours. Okay, from this definitely 2 marks question will come every year from last okay around, you can observe 4, 5 years or 10 years, every year almost the question is coming. Okay, so fine. So note down the next question. Okay. Okay, so this is a high priority process. Okay, highest number is highest priority. Now take out the bus times here. Okay, so they are the bus times. So think carefully and solve. So think carefully and solve. So I am repeating 2 times. Okay, if you do simple mistake also, you get the wrong answer. So it's a good question. So even if you do simple mistake, you get the wrong answer. So copy the question properly, think carefully and solve. The next video, you will see the solution. Okay, so let's try to solve the problem. So question is simple, but only calculation is lengthy. So you have to check the calculations properly. So I explain the Gantt chart and directly give the answer. Okay, calculation you can solve. That is not writing. Okay, now fine. So just make a proper observation, understand here. So first process coming at the time 2. Okay, look at here, time 2 पे आ रहे हैं. So it means 0 to 2 the CPU will be idle. 0 to 2 CPU will be idle. So at the time 2 which process is available? Only P4 available. So no confusion, that we start with the P4 first. And P4 requires how much here? 8. But remember, okay, it's a preemptive priority. I told you already. For every 1 unit of time, you have to check the high priority process. But remember, if you keep on checking 1 unit of time unnecessarily, time will waste. So you have to check, okay, think about the proper arrival times and everything observe properly. देखो P4 को 8 सेकंड चाहिए. P4 के बाद नेक्स्ट प्रोसेस क्या टाइम पे आ रहा है? अराइवल टाइम्स देखो यहाँ पे, नेक्स्ट प्रोसेस देखो 4 पे आ रहा है. मतलब टाइम 4 तक, मतलब ये P6 आने तक, दैट इज द ओनली हाई प्रायोरिटी प्रोसेस, दैट इज द ओनली प्रोसेस अवेलेबल. फर्स्ट ऑफ ऑल दैट इज द ओनली प्रोसेस अवेलेबल. P6 आने तक ये एक ही प्रोसेस है, तो क्या करो, P6 आने तक इसी को चलाओ. ओके, इट मींस हाउ मेनी सेकंड्स यू कैन एग्जीक्यूट, ओके, टिल द टाइम 4. इट मींस हाउ मेनी सेकंड्स यू कैन एग्जीक्यूट? 2 सेकंड्स. इज दैट क्लियर? सी 1 यूनिट करना बोल के गारंटी नहीं है. अपन प्रीवियस क्वेश्चन में 1 यूनिट क्यों कर रहे थे? बिकॉज फॉर एवरी 1 यूनिट द न्यू प्रोसेस वाज कमिंग देयर. For every 1 unit there is new process coming, so that is the reason I was checking for 1 unit of time. Is that clear? Right? So okay, you have to think, okay, observe the values properly and solve. So look at here. So next P6 coming at the time 4. So till the next 2 seconds there is no other process available. So till the next 2 seconds only P4 available. Execute for 2 seconds, that is 4, and the remaining time will be what here? 6. And next present time is 4. By the time 4, is there another process available? Yes, P6 available. Now these two are available. Among these two, who is having high priority process here? Among these two, who is having high priority here? Observe here. This having priority 4, this having priority 6. High priority is your P6. So take up the P6 next. Now P6 requires how much time here? 7. Okay. Now look at here. P6 requires 7. By the time 7, okay, it requires 7 here. But the after P6, next process coming at what time? Observe the values here. Observe the values. Next process coming at the time 6. तो इसका मतलब अगला 2 सेकंड तक दिस इज द ओनली हाई प्रायोरिटी प्रोसेस अवेलेबल. फॉर द नेक्स्ट 2 seconds दिस इज द ओनली हाई प्रायोरिटी प्रोसेस अवेलेबल. सो execute डायरेक्टली फॉर हाउ मेनी सेकंड्स? 2 seconds. सो execute फॉर 2 seconds, दैट इज 6, एंड द रिमेनिंग टाइम क्या होगा बताओ? 5 होगा. राइट? सो नाउ प्रेजेंट टाइम इज 6. बाय द टाइम 6 अभी ओके P2 आ चुका है. नाउ अभी कौन कौन अवेलेबल है? P2, P4 and P6. So among the available, who is the high priority here? Among the available P2, P4 and P6. Among the available, who is the high priority process? This requires 8. This having high priority 8, and this 4, and this 6. So high priority is here. Okay, P2 here. Okay, right. So next we'll take up the P2 next. So take up the P2. So P2 requires 9 here. But how many seconds you can execute directly? Check out the arrival times here. देखो ये 6 पे आया था. अभी नेक्स्ट प्रोसेस क्या टाइम पे आ रहा है? देखो यहाँ पे 8 पे आ रहा है. ऑब्जर्व केयरफुली. नेक्स्ट प्रोसेस क्या टाइम पे आ रहा है? 8 पे आ रहा है. तो इसका मतलब फॉर द नेक्स्ट 2 seconds दिस इज द ओनली हाई प्रायोरिटी अवेलेबल. फर्स्ट एग्जीक्यूट फॉर 2 seconds, लेटर वी कैन ऑब्जर्व. ये आने के बाद कंपेयर करेंगे कि इसका हाई प्रायोरिटी है. सिंपल सी बात. सो नेक्स्ट प्रोसेस आ रहा है टाइम 2 पे, सो इसको 2 सेकंड चला दो. सो एग्जीक्यूट 2 seconds, दैट इज 8, एंड रिमेनिंग टाइम विल बी 7. Now present time is 8. By the time 8, who is available now? P5 also available. अब बताओ कौन कौन अवेलेबल है? कौन कौन अवेलेबल है? P2 अवेलेबल है, P4, P5, P6. अवेलेबल में हाई प्रायोरिटी किसका है? अवेलेबल में हाई प्रायोरिटी देखो यहाँ पे इसका 8 है, ओके, इसका 4 है, 7, 6 है. सो दिस इज द ओनली नेक्स्ट हाई प्रायोरिटी प्रोसेस है. तो क्या करना पड़ेगा? इसी को चलाना पड़ेगा. राइट? अवेलेबल में ये दिस इज द ओनली हाई प्रायोरिटी प्रोसेस. राइट? सो इसी को चलाओ. सो इसी को चलाओ. नेक्स्ट ये टाइम 6 पे आया था, ये टाइम 8 पे आया था. नेक्स्ट प्रोसेस क्या टाइम पे आया? देखो 9 पे आ रहा है. तो इसका मतलब और 1 सेकंड चलाओ P2 को और 1 सेकंड चला रहा हूँ 9. तो इसका रिमेनिंग टाइम क्या होगा? 6. नाउ प्रेजेंट टाइम इज 9. देखो अभी प्रेजेंट टाइम 9. इज देयर एनी अदर प्रोसेस अवेलेबल? यस. ओके, P3 भी अवेलेबल है. हाँ बताओ अभी कौन कौन अवेलेबल है बताओ. ओके, ये सारे अवेलेबल है. 2, 3, 4, 5, 6 अवेलेबल है. अवेलेबल में हाई प्रायोरिटी किसका है? देखो 8, 7, 4, 7, 6 हाई प्रायोरिटी किसका है? P2 का ही है. तो इसका मतलब क्या करना? P2 को ही कंटिन्यू करना. ओके, राइट, कंटिन्यू विद द P2. नेक्स्ट हाउ मेनी सेकंड्स? अब बताओ नेक्स्ट प्रोसेस क्या टाइम पे आ रहे थे? 12 पे आ रहा था. So इसका मतलब present time is 9. The next process coming at the time 12. So it means for the next 3 seconds there is no other process available. For the next 3 seconds this is the only high priority available. For the next 3 seconds this is the only high priority available. So execute for next 3 seconds. So that is 12. I have executed 3 seconds. So what the remaining time here? 3. Remaining time is 3. Now present time is 12. Now tell me by the time 12, okay, P1 is also available. Now observe here, all the processes are arrived. All the processes are arrived. So once all the processes arrived, no need of checking 1 unit of time. Once all the processes arrived, no need of checking 1 unit of time. So you can directly execute what? Okay, high priority process. You can execute directly high priority process. So present time is 12. So by the time 12, all are arrived. Now who is the high priority process among all that? Okay, that is P1. So directly execute with the high priority process P1. P1 requires 8. So 12 plus 8, 20. So that is completed. And next after P1, who is the next high priority process? Okay, observe here. Who is the next high priority process here? P2. So take the P2 next. P2 requires 3. That is 23. That becomes 0. And next okay, next high priority. After that, if you observe, Okay, this also having priority 7, this also having priority 7. So दोनों का priority match हुआ, priority match हो तो किसको देखना, arrival time. So this having arrival time 8 and this having arrival time 7. Who is having a, okay, वो दोनों में कौन पहले आ रहे थे बताओ, दोनों में कौन पहले आ रहे हैं, okay, that is P5. Okay, so ये 8 पे आ रहा है, ये 9 पे आ रहा है तो right. So next, okay, दोनों में कौन पहले आया, P5. Okay, so P5 requires how much here, 9. So how much is that, 33, 32, right? 23 plus 9, 32. Okay, correct? There's a small mistake. Where? P2? P2 executed how many seconds here total? P2 6 to 12. So 6 seconds here, 3 seconds here, 9 seconds, correct? Huh? Right. So next, okay, so there's a P5 is completed, right? So P5 requires 9, so that is P5 completed, so that is 0. And next, so after that, right. So next, understand here, any calculation mistake is there, please check it out, don't worry. So next, okay, after that, who is the next high priority processor? After P5, next high priority is P3. So take out the P3 here. Okay, right. So P3 requires how much here? 6. So that is how much here? 38, correct? So that is 0, that's completed. Now, okay, next, what is pending now? Who is the next high priority process after that? Okay, P6. Look at here. So this is having priority 4, this is having priority 6. So दोनों में next high priority here P6. So P6 requires how much here? Okay, 5. So that is how much here? 43. Okay, P6 completed, and afterward last one is your P4. So P4 requires okay, how much here? 6. So that is 49. Correct? So check the values properly. So this is how you have to solve the problem. Okay. So just okay, make the proper calculation and take out the completion time and find out the answer. Okay. Right. Tell me the answer. Okay. We'll write down the completion times. Okay. So check out the completion times. Now tell me P1 completion time 20. So P2 completion time 23 and P3 completion time 38. Okay, P4 completion time 49 and P5 completion time 32. P5 completion 32 and P6 completion time 43. Okay. So I have written the completion times. So please make the calculation. Okay, right? So check out the values and make out the turnaround time, find karo, average waiting time nikalo. Is that clear? So check properly. Do you want me to solve that? Small calculation, you can do that. Okay. So okay, please check the calculation and find out the answer. Okay, so next we'll take up the next question. So this is the gate question we are going to solve. Page number 85, question number 29. So go to your workbook. So check in the workbook. Page number 85, question number 29. Keep the workbook just beside you. Read the question. Read the question fast. I will just give you the simple hint. Later I will explain the question. Page number 85, question number 29. Okay. Now just listen here. Okay, you can pause. If you are still reading the question, pause my video. After that, listen to my hint. Now I am just want to give you a small hint, okay, before you solve the question. Now he says consider two process P1, P2 and all that. Okay, don't ऐसे ही देखते रहेंगे तो क्वेश्चन सॉल्व नहीं कर सकते, ऐसा देखने से आंसर नहीं आएगा. Okay, that is a logical question in the CPU scheduling. So please make a proper table. Okay, you are having two process P1, P2, arrival time 0, 0 because both are creating nearly at the same time and both of which alternate with the 10 seconds of CPU burst with 90 seconds of IO burst. Okay, so make the table CPU time, IO time, CPU time, IO time like that 10, 10, 80, 80, 10, 10, 80, 80 something like that. Okay, then okay, proper table बनाने के बाद एक एक ऑप्शन से ज्ञान चार्ट बना के ऑब्जर्व करना पड़ेगा. You have to make the Gantt chart by using every option. Okay, like make the Gantt chart by using FCFS, first come first serve. Make the Gantt chart by using SRTF and also round robin and also priority. So after that, you think what is asking in the question. Okay, so if you just look at the question, you will not solve. That is a logical question in the CPU scheduling, one of the good question. So please pause my video and solve that. Try to solve that question. I will wait 5 seconds in the live. Okay, otherwise I will explain. After that I will explain. Okay. Now, so if you are still solving, you can pause my video. Just try to solve the question. So how you are thinking and how I am solving. Now, okay, let's make the table first. Process number. Okay, process number and okay. Process number, arrival time, CPU time, IO time. So CPU time, IO time. So processes are okay alternating like this. Okay, CPU time, IO time, CPU time, IO time like this. So you are having two process P1, P2. Arrival times are 0, 0. So now look at here, CPU time 10. Okay, IO time is 90, 90. So both of which alternate 10, okay, 10 seconds CPU time, 90 seconds of IO time. Okay, so same thing will continue like this. Now remember, somebody doing mistake, okay, even in writing the times also, somebody did the mistake like this, somebody writing 10, 90, 90, 10, something like that in the wrong manner. So that is wrong. Understand the question properly. Understanding the question is also very important. So first, okay, each process, okay, both the process alternate with the 10 seconds of CPU bus, 90 seconds of IO bus. 10 seconds of CPU bus, 90 seconds of IO bus. So same thing will continue like this. So first, let's make the Gantt chart by using FCFS, first come first serve. So all of you know first come first serve, right? So we already discussed. Now, okay, look at here. So time always starts at 0. Time always starts at 0. At the time 0, both are available. So which one you take now? P1. So let's take the P1 first. P1 requires 10. So directly execute for 10 seconds. So that is 0. And next, so after that, now look at here, now P1 completed CPU time and P1 is ready for what? IO time. And P2 is ready for what? CPU time. Okay, so P2 ready for CPU, take the P2 here, 20. Okay, that is 0. And now look at here, when P2 executed for 10 seconds of time and this will become what? 10 seconds of IO it will complete, that is becomes 80. Yes or no? I am not writing proper manner like who is ready for CPU and IO time and all that because it is very easy. Okay, that is the reason I am not writing all that. So when P2 was executing CPU time and P1 was ready for what? IO. Is that clear? So when P2 executed for 10 seconds of CPU, P1 completed 10 seconds of IO. So remaining time will be what? 80. So now this requires 80 seconds of IO, this requires 90 seconds of IO. So now the CPU will be idle for how much time? 80 seconds. 80 seconds CPU will be idle. This requires 80 and this requires 90. So total how many seconds CPU will be idle? Okay, 80 seconds CPU will be idle. Understand here? Because 80 seconds khatam hote hi kya hoga? It will be ready for what? CPU. Right? So now look at here. So 80 seconds CPU will be idle. So in this 80 seconds, what happens here? दोनों का IO parallelly होगा. Question में बताया every process having its own IO resource. Okay, now this becomes 0 and this becomes what? 10 here. And next, now present time is 100. Okay, look at here. Now who is ready for CPU now? P1, because P1 completed IO, ready for CPU. Now, so you take the P1 next, that requires 10, so that is 110. Now that becomes 0, that becomes 0. And next, okay, now again who is ready for CPU now? P2. Now look at here, P2 ready for CPU. Now who is ready for IO now? P1 ready for IO. So now, okay, P2 ready for CPU, so that is 120. Look at 10 seconds. अब बताओ जब इसका 10 seconds CPU खत्म हो गया, so इसका 10 seconds क्या होगा? 80 seconds. IO खत्म होगा तो 80 बचेगा. So now again, this requires 80 seconds of IO, this requires 90 seconds of IO. Now again the CPU will be idle for how much time? Again CPU will be idle for how much time? 80 seconds. Now in this 80 seconds of time, this becomes 0 and this becomes 10. Now again the same thing will continue like this. Okay, the processes will alternate in the same manner. Okay, next you will take again P1, P2 again. Okay, same ideal, same thing will continue. So what you observed, what is the observation you made here? The observation is, okay, when you make executing this Gantt chart here, the CPU will be idle for 80 seconds, 80 seconds, 80 seconds, 80 seconds. So same thing will continue in the same manner. Now that is the case with the FCFS. Now think about option B here. Option B is SRTF scheduling. If you observe the SRTF scheduling, shortest remaining time first. अब बताओ, okay, if I take SRTF and try to make the Gantt chart, how the Gantt chart will look like? If I take the SRTF algorithm and if I make the Gantt chart, how it will look like? Remember, that looks exactly same. Remember, SRTF में फर्क कब होगा? अगर किसी का छोटा बस टाइम है, किसी का बड़ा बस टाइम है, तो फर्क होगा, राइट? बोथ आर हैविंग सेम CPU टाइम, तो कहां से डिफरेंस होगा? ओके, सेम थिंग विल कंटिन्यू, एग्जैक्टली सेम, नो चेंज एट ऑल. And next, if you go with the priority, so he said that static priority बोला है. Static in the sense what? Constant. Okay, you can take a priority. Okay, so priority is having 10, it's having 5. Okay, you can take anything, no problem. Okay, you can take this having high priority or this having high priority, whatever it is. Static priority, okay, it means what? Dynamically change नहीं होगा, बस इतना ही है. Okay, no confusion and all that. So static priority means constant. Just think about that. Now understand here, अगर मैं priority से भी Gantt chart बनाता हूँ, even if you make Gantt chart by using priority, so Gantt chart remains same. There is no difference at all. Okay, CPU will be idle for 80 seconds, 80 seconds, 80 seconds. So same thing will continue like this. There is no difference. So what do you understand here? So in the option A, B, C, there is no difference at all. It is all exactly same. Exactly same. Now remember, the right answer is D. D is the right answer. Option D is the right answer. Okay, those who have not solved, still, okay, you can pause my video and think what is happening in the round robin and why round robin is the right answer. Because you have to improve your logical skills. जो भी आइडिया है तुमको आना चाहिए. इज दैट क्लियर? समझ में आया? ओके, नाउ अंडरस्टैंड हियर. सो लेट्स मेक द टेबल एंड आई विल ट्राई विद द राउंड रॉबिन. लेट्स से आई एम राइटिंग अगेन प्रोसेस नंबर, अराइवल टाइम, CPU time, IO time, CPU time, IO time. Okay, same manner, right? So you're having two process, P1, P2, arrival times are 0, 0. So that's 10, 10. Okay, 90, 90. So 10, 10. Okay, 90, 90. So same thing will continue like this, right? Now let's make the round robin. Okay, option D. What is it in the option D? Round robin with the time quantum is given as what? 5. Round robin time quantum is given as 5. Now understand here, time quantum is 5. Round robin में arrival times are same. Look at here. Let's make the Gantt chart here. So hope this is visible. Okay, visible, right? Right. So now understand here, in the round robin, let's make the round robin. Okay. Now time always starts at 0. Now in the round robin, arrival times are 0. Okay. Now tell me what happens in the round robin. Arrival times are 0. Arrival times are 0, 0. So if the arrival times are 0, 0, arrival times are same in the round robin. How you execute? Same. P1, P2, P1, P2, P1, P2, P1, P2. Same thing will continue like this. Okay, right? So now, so time always starts at 0. So okay, both are available. So ready queue में लिखोगे. Round robin मतलब ready queue से करना पड़ेगा. Ready queue लिखना पड़ेगा. Okay, but okay, it's very easy. So I'm not writing ready queue. बहुत easy है क्योंकि P1, P2, P1, P2 ऐसे ही चलाने का, right? So take the P1, right? Now tell me, P1 requires 10 units of time. Now tell me, but you will execute how much time here? Okay, 5, because time quantum is 5. Okay, so execute only 5 seconds. So that is 5. Remaining time will be 5. Next you take what? P2. Now P2 also requires 10, but you will execute only 5. So that is 10. That becomes 5. Next, okay, next you take the P1. P1 again you take. Okay, that is 5. So that is 15. Now that becomes 0. Now look at here. So now P1 completed CPU ready for what? IO. Now P2 ready for what? CPU. So now next you take the P2 next. Now P2 requires 5. Anyway time quantum is also 5. That is 20. Now okay, जब इसको 5 सेकंड चला रहा है तो इसका 5 सेकंड IO खत्म होगा तो क्या होगा? 85 होगा. Is that clear? ये आइडिया आपको आना चाहिए. This idea you should get. Okay, when I execute 5 seconds here, this becomes 0 and this becomes how much here? Okay, 85. सो इसका मतलब P1 P2 का जब ये 5 सेकंड खत्म हो रहा है, सो P1 का 5 सेकंड क्या होगा, ओके ये IO खत्म होगा, सो रिमेनिंग विल बी हाउ मच 85 here. So now understand here, now this requires 85 seconds of IO, this requires 90 seconds of IO. Now the CPU will be idle for how much time, 85 seconds. So understand here, so 85 seconds CPU idle, so that is 100 plus 85, 105, so 85 seconds CPU idle hoga. Now in this 85 seconds what happened, this becomes 0, this becomes 5. So now next you take the P1 requires 10 again, so same, that becomes 110, that is 5 and remaining, okay this will be 0. Okay, and next you take a P2, so P2 requires 10 but you execute only 5 seconds, that is 115 and that becomes 5. And next you take a P1, okay that is 120, that becomes 0. And next you take P2 here, now tell me again, okay this requires 5, so anyway time quantum is also 5, 125, abhi kya hoga, this becomes 0, this becomes again how much, 85, very good, so that becomes 85. Again the CPU will be idle for how much time, 85 seconds. This requires 85 seconds IO, this requires 90 seconds IO, and CPU will be idle for 85 seconds. 125 plus 85, that is 210. So this 85 seconds CPU will be idle and that becomes 0, that becomes 5. So now again, okay, in this what is happening here, in the round robin you are making the observation that CPU will be idle for 85 seconds, 85 seconds, 85 seconds, 85 seconds. So CPU will be idle in this like, okay, in this manner. So CPU will be idle for 85, 85 and 85. Now understand the question. What is asking the question? Now just read the last line of the question. What is asking? Last line. Which of the following scheduling strategy will give you least CPU utilization? मतलब कम CPU utilization कौन देता है? So कम CPU utilization मतलब least CPU utilization means idle time क्या होना चाहिए, ज्यादा होना चाहिए. इज दैट क्लियर? CPU utilization कौन कम देता है ये आपको पूछ रहा है. CPU utilization कौन कम देता है मतलब किस में idle time ज्यादा होगा वो CPU utilization कम देगा. इज दैट क्लियर? सो किस में idle time ज्यादा है, idle time ज्यादा किस में, राउंड रॉबिन में idle time ज्यादा है. इज दैट क्लियर? So okay, least CPU utilization means idle time should be greater, more. Okay, so which is giving more idle time here? Round robin. So round robin is the right answer. Is that clear? So this is how, okay, you need to solve the problem. Okay, so this is one of the good question, okay, based on the CPU time and IO time concept. Logical question in the CPU scheduling. Is that clear? So what are the questions pending? Okay, based on this concept, they are in the workbook. So try to solve them. Thank you. Dear students, so please listen to here. Okay, hope you are following all the classes carefully, and the next we'll move on to the next scheduling algorithm. So just listen here. In the continuation we'll move on to the next scheduling algorithm, that is the highest response ratio next. Now remember, in the previous sessions, okay, we have seen priority based scheduling in the previous session. So hope all the things are clear. So please try to solve workbook problems whatever you can. I will discuss how to solve everything. Okay, small doubts will be there. Don't worry, I will give the clear instructions about the workbook. So don't need to think about all that. I will discuss everything in the class. I told you in the first day class itself. Now, okay, so just listen here. Next we'll move on to next scheduling algorithm, that is the highest response ratio next. So highest response ratio next, okay, what is this algorithm? So we'll define two parameters. So one is same thing as usual, criteria of the algorithm, and next mode of the algorithm. Now remember two parameters, criteria and mode of the algorithm. So now understand here, the criteria in the algorithm is response ratio. Criteria in the algorithm is response ratio, and mode of the algorithm is non-preemptive. So please listen carefully. Mode of the algorithm is non-preemptive. So criteria in the algorithm is what? Response ratio. What is the meaning of response ratio and how you are going to calculate the response ratio? Okay, listen here. Response ratio will be calculated by using formula. Response ratio will be calculated by using formula W plus S by S. Please copy the notes. Copy the notes. Response ratio will be calculated by using the formula W plus S by S. So what is the meaning of W in this? The W means waiting time. Waiting time. and S means okay, you say it is service time, okay, service time or bus time, service time or bus time, okay, understand here. So how you are going to calculate waiting time and what is the bus time will be given to you, so you will understand everything with the problem. Now, so before we move on to the question, understand some point, okay, keep it as note, keep it as note, note down some statement. The highest response ratio next scheduling algorithm, the highest response ratio next scheduling algorithm favors, मतलब favor करना, favors shorter jobs. Highest response ratio next, okay, scheduling algorithm favors shorter jobs and limits, limits, limits the waiting time of longer jobs, limits the waiting time of what, longer jobs, okay, limits, limits मतलब limits, okay, कम करता है, okay, limits the waiting time of longer jobs. So just that is the important note, remember that. I'll discuss what is the meaning of that, उसका मतलब क्या होता है, I will explain that, okay, don't worry. And the next, so how you are going to calculate response ratio, everything, so we'll try to understand by taking some question, okay, note down the question. So the first question I will explain, process number, arrival time, okay, bus time, note down the question. So you are having 5 processes, okay, 1, 2, 3, 4, 5. So let's say 0, 3, okay, 4, 6, 7. So copy this, 2, okay, 6, 9, 5 and 1. So copy these values. I will explain. So how we calculate response ratio and everything. So we will discuss all that. So please copy the question first. Okay. You can pause the video and copy the question. So as usual, what we need to find out? We need to find out average turnaround time of the processes and average waiting time of the processes. Okay, we need to find out these two. Okay, now understand here. Okay, first same thing. Okay, first as usual, time always starts at 0. Okay, listen carefully. So time always starts at 0. So at the time 0, which process is available? Only P1 is available. Now understand here, response ratio is what? Okay, criteria is the response ratio here. It means what? When more than one process is ready for execution. When more than one process is ready for execution, the decision making of selecting the process will be done based on the response ratio. Okay, whichever is having highest response ratio, that will continue the execution. Is that clear? So that is the meaning of that. So now, okay, first at the time 0, only one process is there, only P1 is there. So no confusion. So directly start with what? P1 first. Okay, so P1 requires how much here? Okay, time 2. Okay, that requires 2 units of time. So it will complete at the time 2. Correct? Now at the time 2, only okay, time 2. Now which process is available? Present time is 2. Which process is available now? Remember, think carefully. What is the present time? What is the arrival time? So at the time 2, there is no other process available. Look at the arrival time here. The next process coming at the time 3. So it means, okay, from 2 to 3, there is no process available. So CPU will be what? Idle. Now at the time 3 again, only one process is there. Now remember, only one process is there. Do we require to calculate any response ratio? No, no need. So directly, okay, take the process P2 here. So P2 requires how much here? 6 units of time. So that's 3 plus 6. That's how much here? 9. Now understand here, now present time is 9. By the time 9, if you observe, all the other processes arrived. P3 arrived, P4 arrived and P5 arrived. Now what you need to find out here? Okay, these 3 are available. Among the available processes, okay, you need to find out that, okay, which one you are going to schedule next. Now how you are going to find out? You need to find out the response ratio of process P3 and response ratio of P4 and P5, and whichever is having highest response ratio, that will continue the, okay, execution. Okay, now we need to find out response ratio of P3, P4 and P5. So how you are going to find out? Okay, listen here. Response ratio of P3, response ratio of P4 and response ratio of P5. So the same formula, W plus S by S. So W plus S by S. So same W plus S by S. Okay, S is the service time. Service time means bus time. Okay. Now how you find out okay, waiting time here? Now remember, the waiting time here is according to present time. Waiting time according to present time. Now I want the waiting time of process P3. Listen carefully. Waiting time of process P3. Now tell me, what is the present time here? Present time is 9. Present time is 9. At what time, okay, the P3 coming here? Present time is 9. At what time your P3 coming here? Okay, 4. अब बताओ कितना waiting time हुआ? Okay, present time is 9 and P3 coming at the time 4. So it means 9 minus 4. How much is that? 5. So waiting time is what? 5 plus service time. Service time means what? Bus time. So that is okay, 9. So 5 plus 9 by okay 9. So this is how much here? 14 by 9. Okay. So we'll find out what is the value. And the next, okay, coming to the P4, find out the response ratio of P4. Present time is 9. At what time P4 coming here? 6. So बताओ present time 9 है, P4 आ रहा है 6 पे, तो कितना waiting time हुआ? 9 minus 6, that is 3. Okay, plus service time कितना है? 5. So that is the 3 plus okay 5 divided by 5. So that is how much here? Okay, this is 8 by 5. And next, now understand here, okay, coming to this okay, P5 response ratio also we need to find out. Present time is 9. At what time P5 coming here? Present time is 9. At what time P5 coming here? 7. So waiting time कितना हुआ? Okay, 9 minus 7. मतलब वही 7 पे आके वेट कर रहा है. अभी तो present time कितना 9 है. तो waiting time कितना हुआ? So 9 minus 7, that is 2. So that is 2 plus okay bus time. Okay, service time is how much here? 1. So now understand here. So 1 divided by 1. Okay. So now this is how much here? 3 divided by 1. Now understand all these values here. Okay. 14 divided by 9. So you get 1 point something here. And next 8 by 5. That also you get 1 point something. And but coming to this 3 divided by 1. That is how much here? 3. So who is having highest response ratio here? P5. Listen carefully. So P5 is having highest response ratio. So now we are going to continue with what? Process P5. So continue with the P5 next. Okay, take the P5. So P5 requires how much time here? Only 1 unit of time. So that is how much here? 10. So now P5 completed. Now remember, once P5 completed, now what is available now? P3 and P4 both are available. Remember, P3 and P4 both are available. Now which one you take now? Again, to decide between P3 and P4, again you need to calculate the response ratio according to the present time. According to the present time. Is that clear? So let's calculate the response ratio, okay, of process P4 and the response ratio of process P5 according to present time. So same formula, W plus S by S. So that is W plus S by S. Okay. So let's calculate that. Now present time is 10. Now tell me waiting time of P4 here. Sorry, P3. Waiting time of, okay, what is pending now? Okay, sorry. P3 and P4. Okay. So sorry. I written P4 here. So P3 and P4. So we have to decide between these two things, right? So P4 and P4. So इसका फिर से response ratio निकालना according to present time. Okay. Present time अपना कितना है बताओ? 10. Now, okay, now P3 coming at what time here? P4, time 4 पे आ रहा है. So P3 का waiting time निकाल रहा हूँ. Listen carefully. Remember, waiting time according to present time. I told you already. So waiting time according to present time. So present time is okay. Present time is 10 and P3 coming at what time here? Okay, 4. तो बताओ इसका waiting time कितना हुआ? 10 minus 4. That is how much here? 6. 10 minus 4, 6. 6 plus 9. So 9 is the burst time. That is 9. So this is how much here? 15 divided by 9. Okay, correct. And next, now coming to the okay P4. Present time is 10. Listen carefully. Present time is 10. At what time P4 coming here? 6. So 10 minus 6. Okay, is how much that? 4. So 4 plus. So what is the burst time? That is having 5. So 4 plus 5 divided by 5. So this is how much here? 9 by 5. Okay. So now look at here. This is 9 by 5. Okay. And this is how much here? 15 by 9. So which value is greater here? Who is having highest response ratio here? P4. Okay. You can check it out. This you get something like 1 point. Okay. So 8 something like. Okay. So you may approximate. I am writing. So maybe 1.8. Okay. Right. Okay. Next this one you get how much here? okay, 1 point, how much here, 1 point, how much is pending, 1, okay, 6, okay. So it means maybe 1.4 or 1.5 something you get. So anyway, this is a greater value. So this is having highest response ratio. Okay. So highest response ratio. Now coming to the P3 and P4, this is having highest response ratio. Next you will continue with what? P4. So continue with the P4 here. So P4 requires how much time here? 5. So 10 plus 5, how much is that? 15. Now P4 completed. And next now last one is what? P3. Okay, understand here. Last one is P3. P3 requires how much time here? 9. So P3 requires 9. Only one process is pending. So no need to calculate any response ratio. Now only one process is pending. No need to calculate any response ratio. So directly take up the P3 next. Now P3 requires how much here? 9. So 15 plus 9. How much is that? 24. So this is how you calculate the you solve the problem. Now so let's take up the completion time. I will write here. I am not going to solve the problem, so you please check it out. So I explained the procedure. Okay, so please check it out. P1 completion time is 2 and P2 completion time 9 and P3 is 24 and P4 is 15 and P5 is 10. So these are the completion times. Now we can find out turnaround time and waiting time. So you know the formulas already I have given. Okay, just for easy understanding I write again: completion time minus arrival time. Waiting time is what? Turnaround time minus bus time. Turnaround time minus bus time. Okay, so please find out the answers and you can actually chart, discuss with your friends what is the answer of this question, highest response ratio. Okay, I think some chart provision is discussion provision is there, in the Mary's Prime app and also maybe in the live app. Okay, I think Prime app I'm not sure, but in the live app it is there. Okay, you can discuss forum kind of thing, discussion forum kind of thing. So please check all the options available. Okay, the Prime students and also live students, please check. Okay. So that is how you solve the problem. So next you are going to solve one more question. So take up the next question and that is a homework for you, because I am not going to explain because it is exactly same, because we have to calculate all the response ratios and all that. So it is time consuming. Okay. Fine. So now listen here, next question you need to solve. So copy this question. You guys please copy this question. Okay, so copy this question and find out average turnaround time and waiting time. So please copy the question. I am not going to use the solution for this and I don't have answer also, because I have just written the question, by observing proper values and all that. I gave you the question. So please copy this question and try to solve it by yourself. Okay. Okay, fine. So if anybody is not copied, so please pause my video and try to copy. Now I will discuss some important point. Just listen carefully. So when I said this algorithm highest response ratio next, I told you, note में कुछ लिखे थे आप लोग, नोट में कुछ लिखे थे, क्या लिखे थे नोट में? क्या लिखे थे? फर्स्ट, the highest response ratio next scheduling algorithm favors shorter jobs and limits the waiting time of longer jobs. ये बात बताया था, right? So इसका मतलब क्या होता है? आप चेक कर सकते हो clearly. थोड़ा सोचो अच्छे से. Understand here. In this response ratio, you are calculating by using formula what? W plus S by S. You are calculating by using the formula W plus S by S. If you observe this, formula, ये formula को थोड़ा समझो, इसको क्या कर सकते? W by S लिख सकते और plus S by S लिख सकते, right? So W plus S divided by S, right? So W by S plus S by S, so S by S cancel हो जाएगा. So indirectly formula ये क्या बन रहा है बताओ? 1 plus W by S. थोड़ा सोचो अच्छे से logically. 1 plus W by S. So 1 is a constant, this value is a constant, okay, that is not having any impact, that is a constant. But remember, what is the formula indirectly it is becoming? W by S. अब बताओ W by S मतलब, इधर सुनो, अगर waiting time बढ़ रहा है, if the waiting time of the process is increasing, देखो ये numerator में है, if the waiting time of the process is increasing, then also response ratio will increase. Understand carefully. If the waiting time of the process is increasing, then also response ratio will increase. And remember, if it is also having shorter bus time भी कम है. Okay, yes मतलब क्या है? कम. Okay, bus time. Yes मतलब service time मतलब bus time. अगर bus time कम भी है, so then also response ratio will increase. Is that clear? See, देखो ये पूरा वैल्यू W by S है. Okay, some parameter. Okay, so okay ज्यादा मत सोचो. Okay, W by S है. अगर ये वैल्यू कब बढ़ेगा पूरा? अगर W बड़ा है तो भी ये पूरा वैल्यू बढ़ेगा रेस्पॉन्स रेशो. अगर यस कम है तो भी ये पूरा रेस्पॉन्स रेशो बढ़ेगा. इज दैट क्लियर? ये न्यूमरेटर है. ओके राइट. ओके न्यूमरेटर बड़ा है तो भी ओके बढ़ेगा, और यस कम भी है तो भी बढ़ेगा. इज दैट क्लियर फॉर एवरीवन? ओके डिवाइडर. सो अंडरस्टैंड हियर. सो इट मींस व्हाट? हाईएस्ट रेस्पॉन्स रेशो नेक्स्ट क्या लिखे थे, पढ़ो एक बार. हाईएस्ट रेस्पॉन्स रेशो नेक्स्ट शेड्यूलिंग एल्गोरिथम फेवर्स शॉर्टर जॉब्स. इसका मतलब जो प्रोसेस का बस टाइम कम है उसको भी ओके फेवर करेगा मतलब ओके जल्दी शेड्यूल करेगा. सिंपल सी बात. एंड लिमिट्स द वेटिंग टाइम ऑफ लॉन्गर जॉब्स. इसका मतलब क्या है? अगर बहुत देर तक वो वेट कर रहा है उसका वेटिंग भी कम करेगा, क्योंकि अगर उसका वेटिंग बढ़ते जा रहा है, if the waiting time of the process increases, the entire response ratio will increase. Okay, and process will get a chance to execute. So ये छोटे प्रोसेस को भी अच्छा कर रहा है, और जो प्रोसेस बड़ा है ज्यादा देर वेट कर रहा है, ज्यादा देर उसको वेट करना नहीं देगा. इज दैट क्लियर? राइट. सो डोंट ऑब्जर्व माय हिंदी. ओके, सो इट मींस ओके इट फेवर्स शॉर्टर जॉब्स एंड लिमिट्स द वेटिंग टाइम ऑफ लॉन्गर जॉब्स. सो दैट इज द ओके इंपॉर्टेंट पॉइंट यू शुड रिमेंबर. सो दैट इज अबाउट highest response ratio next scheduling algorithm. Okay, so next in the continuation, in the next scheduling algorithms whatever we have, we will discuss the next scheduling algorithm. So in the continuation, so that is multi-level queue scheduling algorithm. Note down, please make a proper copy. Multi-level queue scheduling algorithm. So what happens in the multi-level queue scheduling algorithm? So please copy this diagram. Multi-level queue scheduling algorithm. We are going to have multiple ready queues. Let's say ready queue 1, ready queue 2, ready queue 3 and ready queue 4. Copy this. I will explain everything and I will give the proper notes. Just listen first. Okay, copy करो अच्छे से. Ready queue is nothing but what? Ready states. Missing all your faces. Hope you are all doing great. If time permits, if the God wishes, we will meet once again. Maybe in the offline. Okay, so I think you guys copied. Now understand here, multi-level queue scheduling algorithm. Understand here. So 2-3 important points will come up in this. Now in the multi-level queue scheduling, we are going to have multiple ready queues. Listen here, we are going to have multiple ready queues like ready queue 1, ready queue 2, ready queue 3 and ready queue 4. See, ready queue is nothing but what? Ready state only, multiple ready states. Now, when you are having multiple ready states, the first question comes, whenever the process is created, in which ready queue you are going to place? In which ready queue you are going to place? पहले सुनो अच्छे से, मैं notes देता हूँ बाद में. Okay, पहले सुनो. No need to copy. I will dictate the notes. Now, okay, first whenever the process is created, in which particular ready queue the process will be placed. Remember, that will be decided based on the priority of the process. That will be decided based on the priority of the process. So, whenever the process is created, in which particular ready queue the process has to be placed, that will be decided based on the priority of the process. Okay. So, depending on the priority of the process, in which particular ready queue the process will be placed will be decided. I will give the notes, sir. Don't copy. First listen. Okay. Depending on priority of the process, in which particular ready queue the process has to be placed will be decided. Now, remember, the high priority processes will be placed in the top level ready queue. High priority processes will be placed in the top level ready queue, and the low priority processes will be placed in the bottom level ready queue. So, high priority process, it means what? High priority process means the process which are having high priority, like example operating system processes. So, operating system processes are considered to be high priority processes and they will be placed in the top level ready queue. Okay. So, and student process, okay, generally considered to be low priority, and remember they will be placed in the bottom level ready queue. So, high priority processes will be placed in the top level ready queue, and low priority process will be placed in the bottom level ready queue. And remember, only after completion of all the processes from the top level ready queue, only after completion of all the processes from the top level ready queue, the further level ready queue processes will be scheduled. इसका मतलब क्या है? So first you are going to complete all the process from the top level ready queue, then only you come to the next level ready queue process, and then only after that you come execute the next level ready queue process. So only after completion of all the process from the top level ready queue, the further level ready queue processes will be scheduled. So why like that? Why? Because obviously the top level ready queue process are having what? High priority, right? Now remember, if this is the strategy followed, then the processes which are placed in the bottom level ready queue will suffer from starvation. Remember, the answer is not just say the processes which are placed in the bottom level ready queue will suffer from starvation. So, what is the meaning of starvation? Okay, and how this is going to occur? Let us discuss that also. Okay, what is the meaning of starvation? Okay, I will discuss everything, okay, in detail. So, before that, make a note of all the points. Please make a note. Note down one by one point. Note down first point. Depending on the priority of the process, in which particular ready queue, the process has to be placed will be decided. In which particular ready queue the process has to be placed will be decided. Full stop. The high priority processes will be placed in the top level ready queue. And the low priority processes will be placed in the bottom level ready queue. Low priority processes will be placed in the bottom level ready queue. Full stop. Only after completion of all the processes from the top level ready queue, the further level ready queue processes will be scheduled. Full stop. If this is the strategy followed, then the processes which are placed in the bottom level ready queue, will suffer from starvation. Okay. Now understand, a process are placed in the bottom level ready queue will suffer from starvation. What is the meaning of starvation? Okay, let us try to understand that also. Starvation means what? Okay, listen here. Okay, note down the definition. Keep the heading starvation. Note down the indefinite the indefinite waiting of a process. The indefinite waiting of a process is called as starvation. The indefinite waiting of a process is called as a starvation. Okay, copy this. Now understand here, what is the meaning of this? Listen here, the indefinite waiting of a process. What is the meaning of indefinite? Remember, what is the meaning of definite? Definite का मतलब क्या होता है? Definite means you are having some specific number. Like for example, after two processes, okay, you will get the process will get scheduled. Okay, process will get a chance to execute. So that is called as what? Definite wait. So it means what? You are having some definite number. Understand carefully. Definite waiting मतलब क्या होता है? You are having proper definite number. Okay, दो process के बाद chance मिलेगा, चार process के बाद chance मिलेगा. That is a definite number. So indefinite means what? You don't have any specific number. It is keep on waiting, keep on waiting. That is called as what? Indefinite waiting. Okay, the answers to know how the starvation is going to occur. क्या लिखे थे? Last point क्या लिखे थे? Last definition, last points में क्या लिखे थे? The processes which are placed in the bottom level queue will suffer from what? Starvation. So how they are going to suffer from starvation? Listen carefully. Let us say, depending on the priority, we have distributed the process. Let's say P1, P2 distributed here, and P3, P4 distributed here, and P5, P6 here, and P7, P8 here. Depending on the priority, we have distributed the process. Okay. Now listen here. Let's say P1, P2 is completed because they are having high priority. So next P3, P4 also completed, and next P5, P6 also completed. Now remember, you are about to schedule P7 and P8. You are about to schedule P7 and P8, and suddenly the new process coming from the coming into top level ready queue. New process coming into top level, like for example P9 coming here, P10 coming here, P11 coming here. Then what happens? These processes will be postponed and we are going to schedule what? Top level ready queue process. Why? Because the top level ready queue process are having what? High priority. Top level ready queue process are having high priority. Is that here? So next you are going to schedule P9 here, and next P10 here, and next P11 here. Let us say you are again about to schedule P7 and P8. Again the new process coming into top level ready queue. That is P12 coming here, and P13 coming here, and P14 coming here. So then what happens here? Okay, again these processes will be indefinitely postponed. So they will be indefinitely postponed. So that indefinite waiting of a process is called as what? Starvation. Is the point clear? The indefinite waiting of a process. इसका मतलब उसका number कब आएगा कुछ पता नहीं है. Okay, keep on waiting, indefinitely wait कर रहा है. So that is indefinite waiting of a process is called as a starvation. Now how we are going to avoid this problem of starvation? Okay, note down. Continuation. Keep it as note. Keep it as note. Note down. To avoid the problem of starvation. Note down. To avoid the problem of starvation, the concept of aging will be used. The concept of aging, I am writing here. The concept of aging will be used. Okay, what is the meaning of aging? Okay, note down. Keep the heading aging. Keep the heading aging. Note down. Note down. If the waiting time of a process, first point, aging में first point लिखो. If the waiting time of a process increases, if the waiting time of a process increases, then the priority of the process will be increased. Then the priority of the process will be increased. Full stop. Note down next point. If the age of a process increases, if the age of a process increases, then by increasing the priority, if the age of a process increases, then by increasing the priority of the process will definitely get a chance to execute. The process will definitely get a chance to execute, and the starvation problem will be avoided. Starvation problem will be avoided. Okay, right. So, aging is a very simple technique. Now, understand here, nothing is there. The first point says, समझ में आना चाहिए. If the waiting time of a process increases, then obviously what happens? The priority of the process will increase. Okay, understand here. If the waiting time of a process increases, then the priority of the process will be increased. Next, second point क्या लिखे? If the age of a process increases, age मतलब क्या है? Waiting time. Simple सी बात. Okay, right? If the age of a process increases, by increasing the priority of the process will definitely get a chance to execute and starvation problem will be avoided. Is that clear? अगर प्रोसेस का वेटिंग टाइम चेक करते रहेंगे, अगर वेटिंग टाइम बढ़ रहा है सिस्टम के अंदर, प्रोसेस का वेटिंग टाइम बढ़ रहा है, ओके, देन क्या करोगे? उसका प्रायोरिटी बढ़ा देंगे. Is that clear? So then what happens? Obviously, if the priority increase करेंगे तो क्या होगा? Okay, process will get a chance to execute and starvation problem will avoid. So this is a simple technique we use to avoid the problem of starvation. Is that clear? But remember, important point, in this algorithm, we are not using the concept of aging. In this algorithm, we are not using the concept of aging. If somebody is asking, okay, in the multi-level queue scheduling, do you have starvation? Yes. In the multi-level queue scheduling, do you have starvation? Yes. Okay, right. So that you should remember. Is that clear? So that is about multi-level queue scheduling algorithm. Next we will discuss the next scheduling algorithm. No doubt. The next one is multi-level feedback queue scheduling. Multi-level feedback queue scheduling. No doubt. Copy this. Copy the diagram. Copy this. I will discuss what is the meaning of multi-level feedback queue and all. You can pause the video and copy. Okay. Now listen here. In the multi-level feedback queue scheduling algorithm, understand here. Here also we are going to implement multiple ready queues. Okay, in the multi-level feedback queue scheduling algorithm also we will implement what? Multiple ready queues. But the implementation strategy is little different. मतलब थोड़ा फर्क है. Okay, यहाँ पे क्या होगा? Listen here. We are using the round robin scheduling with the gradually increasing time quantum. In the round robin, okay, in the multi-level feedback queue, we are using round robin scheduling with a gradually increasing time quantum. Okay, now look at it. So in this ready queue, we are using round robin scheduling with time quantum 2. In this, we are using time quantum 4. In this ready queue, we are using same round robin with time quantum 4. And the last scheduling algorithm, we are using what? FCFS, first come, first serve. Now, यहाँ पे क्या होगा? In the multi-level feedback queue scheduling algorithm, all the processes will be placed in the top level ready queue only. So whenever the process is created, all the processes will be placed in the top level ready queue only. Now remember here, the process will definitely get a chance to execute for some amount of time. Process will definitely get a chance to execute for some amount of time. Matlab it is executing for time quantum 2. So remember, if it is completing with the time quantum 2, then it will go to what? Termination state. Okay, if it is completing with the time quantum 2, then it will go to what? Termination state. Otherwise, process will be interrupted and placed in the next level ready queue with the remaining bus time. Otherwise, process will be interrupted and placed in the next level ready queue with the remaining bus time. So here it will execute for the time quantum 4. If it is completing the execution, it will go to the termination state Otherwise, okay, it will be interrupted again and that will be placed in the next level ready queue with the time quantum 8. Okay, इसका मतलब क्या होता है? Listen carefully. Okay, next in here it will execute for time quantum of 8. If it is completing execution, it will go to termination state. अगर यहाँ पे भी complete नहीं हो रहा है, then it will be interrupted again and placed in the next level ready queue with the remaining bus time. And in this you are using FCFS algorithm and you will definitely complete the execution. Okay. Now, okay, what is the meaning of this? If anybody is having doubt, listen here. Let's say process is having bus time of 10. Just an example. Process is having bus time of 10. So here it will execute for the time quantum 2. If it is completing execution, it will go to termination state. Ab batao, okay, this requires 10. Na? Here execute, it will execute how much time here? 2 units. Now, will it complete the execution? No. So, okay, it will be interrupted and placed in the next level ready queue with the remaining bus time. So, what is the remaining bus time? So, 10 में से 2 गया. So, remaining bus time will be what? 8. And remember, next year it will execute for time quantum 4. If it is completing the execution, it will go to the termination state. Otherwise, it will interrupt again and place in the next level ready queue with the remaining bus time. So, what is the remaining bus time here? Okay, 8 में से 4 गया. So, remaining will be what here? 4 only. Okay, so here it will complete the execution, it will go to termination state. अगर यहाँ पे भी complete नहीं हो पाता, so then it will be interrupted again and placed in the next level ready queue with the remaining bus time. So यहाँ पे FCFS होगा and it will definitely complete the execution. Right? So this is the multi-level feedback queue scheduling algorithm. Now in this there is small advantage and also disadvantage again. So advantage is what? Here every process will definitely get a chance to execute for some amount of time. In this, every process will definitely get a chance to execute for some amount of time, but still there is a possibility of starvation. Still there is a possibility of starvation. यहाँ पे भी starvation होने का chance है. कैसे होगा starvation? Okay, understand here. Let us say you are having some process P1. The answer सुनो अच्छे से. Process P1 is there. P1, okay, if it is executing time quantum 2, यहाँ पे complete नहीं हुआ, so then it will come to next level ready queue. Let's say here it will execute time quantum 4. Let's say यहाँ पे भी complete नहीं हुआ, so then process will be interrupted and placed in the next level ready queue. Let's say process P1 यहाँ पे. Listen carefully. Listen carefully. So P1 is placed in the top level ready queue. Okay, it is not completed here and will placed with the remaining bus time here. Here also it is not completed and interrupted and placed in the next level ready queue with the remaining bus time. So now P1 is here. Now remember, process P1 will be scheduled only if there is no process present in the top level ready queue. It means what? If the new smaller processes keep on coming, listen carefully. If the new, okay, नया process, छोटे वाले नया process आते जा रहा है. If the new smaller processes keep on coming, example with the bus time 1. Look at here. New processes, okay, like P2, okay, P3, okay, P4, like this. Okay, नया process छोटे वाले आते ही जा रहे. If the new smaller process keep on coming, and this will go into what? Indefinite waiting. इसका मतलब, so P2 आया, time quantum 1 था और bus time 1 था, तो ये complete करके चले गए. उसके बाद P3 आया, ओके, टाइम क्वांटम 1 था, ओके, सॉरी, बस टाइम 1 था, तो कंप्लीट करके चले गया. सो P4 आया, बस टाइम 1 था, तो यहाँ पे कंप्लीट करके चले गया. सो इन द सेम मैनर, इफ द प्रोसेस कीप ऑन कमिंग विद अ शॉर्टर बस टाइम एंड दे आर गोइंग. So remember, if the new smaller process keep on coming and this will go into what? Indefinite waiting. Why? Because if there is no process present, then you schedule this process. If there is no process present, then you schedule this process. If there is no process present, then you schedule this process. Is that clear? So that is the strategy we follow. Is that clear? Right. So now in this case, there is a still possibility of what? Starvation. Is that clear? So, okay, some textbooks will say to avoid the problem of starvation, here they will apply what? Starvation. Okay. Now remember, in the multi-level feedback queue, in case if I apply aging concept, okay, some textbooks they say, okay, now they are applying, okay, to avoid the problem of starvation, they are applying aging. In this, if you apply aging concept, okay, aging concept अपन पढ़े थे, okay, then the starvation will be avoided. Is that clear? तो क्या होगा, इसका प्रायोरिटी बढ़ा के क्या करेंगे अपन? ए रेडी क्यू में प्लेस करेंगे. ओके, इसका प्रायोरिटी बढ़ा के क्या करेंगे? ए रेडी क्यू में प्लेस करेंगे. सो इन दैट केस, ओके, एजिंग कॉन्सेप्ट अगर यूज करेंगे, इफ यू अप्लाई द एजिंग कॉन्सेप्ट इन द मल्टी लेवल फीडबैक क्यू, आई एम रिपीटिंग, if you apply aging concept in the multi-level feedback queue, then there is no starvation. But by default, there is no aging concept applied. So by default in the exam, if somebody is asking in the multi-level feedback queue, do you have starvation? Yes, we have a starvation. In the multi-level feedback queue, do you have starvation? Yes. In the multi-level feedback queue, they applied aging concept. Do you have starvation? No, there is no starvation. Is the point clear? Right. So, make a proper notes. So, now this is okay, little interesting. We will try to take up some question, okay, so that okay, you will have a clarity. Okay, let us discuss the question from the workbook. So, go to your workbook. Go to your workbook. I am assuming all of you received workbook. In case if you are not received, so please follow up with the MedEasy office, because we cannot write the complete question, because some questions are lengthy, some questions are small. Okay, it will waste your time. So, go to your workbook, page number 83. So, I am writing here page number 83, question number 8. Question number 8. So, just read that question and try to solve. So, I will wait 10 seconds in the live. You can pause my video. Page number 83, question number 8. Pause my video and try to solve. Okay. Now, let us discuss the question. So, he is saying the bus time of the process. Bus time of a process is how much here? 40. So, that is given to you. Bus time of a process is 40, and is using the multi-level feedback queue scheduling, and queue time quantum is 2. Queue time quantum is 2, and in each level it is incremented by what? Okay, 5 units. So, it means what? क्या लेना है आपको? यहाँ पे 2 लेना है, and next यहाँ पे 2 plus 5 7 लेना है, and 7 plus 5. Okay, that is 12, 12 plus 5, 17, 17 plus 5. So, that is how much here? 22. Correct? So, this is how you have to take first. Next, now tell me, so bus time is 40 here. So, it will be placed with the time quantum 2 here. Now, in this, will it complete the execution here? No. Okay. So, time quantum सिर्फ 2 सेकंड चलेगा. So, इसका bus time 2 सेकंड खत्म हुआ, तो यहाँ पे complete नहीं हो रहा है. देखो, first time you are interrupting the process. You are interrupting the process and placing the next level ready queue with the remaining bus time. So, what is the remaining bus time? 38. So, 40 में से 2 गया, तो remaining bus time 38. So, here it will execute for the time quantum of 7. So, now tell me, will it complete the execution here? No. So, here also it will execute for time quantum 7. It will not complete. Again, you are interrupting. देखो, second time you are interrupting the process and place in the next level ready queue with the remaining bus time. So, what is the remaining bus time? Okay, that is okay, 38 में से 7 गया. So, that is 31. And next, here will execute for the time quantum 12. यहाँ पे भी complete नहीं होगा. Third time you are interrupting the process. 31 minus 12. So, how much is that? 19. So, here you execute for the time quantum 17. यहाँ पे भी complete नहीं होगा. देखो 19 seconds bus time है और time quantum 17 है. So, देखो fourth time you are interrupting the process and you place that in the next level ready queue with the remaining bus time. So, that is 2. So, here anyway time quantum 22 है. So, it will complete the execution. Okay. Now, in the question is asking what? How many times the process will be interrupted? Now, tell me how many times interrupted? 1, 2, 3, 4. So, 4 times the process will be interrupted. And in which ready queue the process will terminate? And which ready queue? Okay. Now, look at here 1, 2, 3, 4, 5. And the 5th ready queue the process will terminate. Okay. So, that is the question. Sorry, that is the answer. So, what is the answer matching here? B. I think B is the right answer. Yes, B is matching. Okay. That is 4, 5. Is that clear? So, this is how, okay, you are going to solve the problem. Right. So, that is the multi-level queue scheduling algorithm. Okay. So, next we will take up some more questions. Okay. So, finding out the throughput of the system, and we will discuss the starvation problem and some other question if possible. Okay. So, thank you. So, hope you are following. So, in the next video, we will continue with the next some more questions.